This section is about electrostatics. Under electrostatics, we have two types of charges which are main components of electrostatics. It is positive and negative charges. Positive represented by plus sign, and negative is minus sign. Let us talk about a positive charged object. If we say that the object is positive charged, it doesn't mean that there are no negative charges in this object. The fact is that positive charges number is greater than of negative charges. Let us take this oval object with some charges inside. We have 4 negative charges, and 4 positive charges. So in this case of equal number of charges, we say the object is neutral. Then this object has 4 negative charges, and 3 positive charges. This object is set to be negatively charged as number of negative charges exceeds the positive charges number. So as for positive charged object, positive charges are more than of negative charges. Note, unlike charges attract each other, that will be positive and negative charges. If they are placed apart with a distance between them, there will be a force in between them. That force is a force of attraction because positive charge will move towards negative charge while the negative is doing the same. May end up touching each other. Once the touch happens, the subtraction on charges and the answer will have the sign of bigger number. Because they are 2, each will take a half and repel each other as they will be having like charges now. That brings us to like charges which they repel each other, so if they are placed apart with a distance in between, there is a force of repulsion in between them. Let us say it happens to be forced to touch each other. They will be an addition on charges and the answer will have the sign that charges were having. Then each will take a half share on the answer and repel away. This forces exist in between charges lead us to Coulomb's law, which states that the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. All this saying is mathematically expressed by this relationship for Coulomb's law. The F is for force measured in newtons, Q is for charge measured in coulomb, and R is for the distance in between charges. That distance is measured in meters. For the force inverse proportional to distance, it means that, when you increase distance, the force decreases. But for the force directly proportional to product of charges, it means that when you increase charges the force also increases. The equation for Coulomb's law is completely written like this, where this K is a proportionality constant which is equal to this number with its units. Now let us move to units of charge. We have been writing this letter C on the charges, now we are proudly saying that C is the SI unit for the charge which named coulomb. There are other 3 types of smaller charges than 1 coulomb which usually the calculations are referred to. Those charges are microcoulomb, nanocoulomb and picocoulomb. So when we equate each to coulomb or for conversion purpose to SI unit, 1 microcoulomb is equal to 10 to power negative 6 coulomb. 1 nanocoulomb is equal to 10 to power negative 9 coulomb. 1 picocoulomb is equal to 10 to the power negative 12 coulomb. Remember, when calculating the force between charged objects or bodies, on your answer, you must indicate whether the force is an attractive or repulsive one. Note, a negative force answer is an attractive force, and a positive force answer is a repulsive force. Now I am sure everything is clear. Let us take this example to clarify more about what we have already said. 2 spheres A and B, on the insulated stands, with charges of negative 4 times 10 to power negative 8, and positive 8 times 10 to power negative 8 respectively, are placed 0.03 meter apart. Now we are required to calculate the magnitude of the force between them and indicate that is attractive or repulsive force. We take all what we are given and pluck them as they are in this Coulomb's equation. We get negative 0.032 Newton. Because is negative, that is an attractive force we got.